Okay, we left off on example 3, where I think this is having us recall that example from the last section, 9.1, about Ricky Bobby and how he was claiming to be an 80% free throw shooter, and when he shot it 50 times, he actually only made 32 of them. So his sample proportion was actually 64%, which was a lot lower than he claimed. And so now that we know how to do a full-blown significance test, we're going to answer the question, does this provide significance evidence against his claim? And a lot of times you'll notice here in this problem, it doesn't give us a significance level. So this is how a lot of the free response questions are worded, and we're just going to pick one and we're going to use 0.05. Okay, so the parameter in question would be Ricky Bobby's true population proportion of made free throws. Okay, the null hypothesis. This is his claim that he's an 80% free throw shooter, and the alternative is, that we're saying that he's less than that, and the alpha level, we're just going to use 0.05. Okay, so I've got some of the conditions filled in here, like a simple random sample, it says of 50 free throws were made, so that meets the random condition. The 10%, we are not really sampling without replacement, okay? Because he's just going to keep shooting. Remember, the 10% is only if you're reaching in, taking something out of a population and not replacing it, but these are kind of independent shots. So since we aren't sampling without replacement, we don't need to check this. Okay. Now I'm writing this here just so when you look back at the notes you understand why we didn't need to check it. You just would skip this. You don't have to write that for the 10% and then write, I don't need to do this. You could just not do the 10% condition. Okay. You can see the large counts condition, therefore normality is met by showing that, you know, at least the number of successes, number of failures would be at least 10. Okay, so as we know now, when we do these significance tests, particularly with proportions, if we're just basing it off of one sample, this is called a one proportion Z test. We're going to use the T, that's where we calculate the test statistic. Okay, we put our population proportion first, minus the parameter, which would come from the null hypothesis, okay, over the standard deviation of the statistic. Okay, that's number of successes times number of failures divided by n, the number in the sample. Okay, that gives us a z-score of negative 2.83. I'm looking back and I'm seeing this is a one-tailed test. So when I draw my curve, okay, z-score of 0 down the middle. Okay, I'm going to go 1, 2, 3 z-scores to the left here and say that right about here is negative 2.83, and I'm doing everything less than that. That's what I want to calculate for our p-value, which is what the O stands for, obtaining a p-value. Okay, this is where we would maybe just use the calculator feature, normal CDF. I'm going to go negative 10,000, comma negative 2.8301. Okay, that's my lower, upper, mean, and standard deviation. That gives me the probability of getting that sample proportion or more extreme or worse, 0.0023. Okay, so we're going to make a decision, and that always links the p-value to its relationship with the alpha level. Okay, so we're saying, look, since the p-value is less than the alpha level of 0.05, our conclusion is we're rejecting the HO. That always means that we are saying, look, we have the convincing evidence we need that's going to be in favor of that alternative hypothesis. So that the true proportion of made free throws is less than 80%. Okay, and if you look back up at what we wrote for the alternative, that was less. Okay? Okay, so let's check out another one here. Okay, this one kind of revisits a potato example that we had looked at earlier, and I already filled in a little bit of this here just to kind of get us going. This says a potato chip producer just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, they send the truckload away to this back to the supplier. Supervisor selects a random sample of 500, so there's 500 in it. And when he inspects it, he notices that 47 of them have blemishes. Okay, so this is going to give us a sample proportion. 47 out of 500, that's going to be 0.094 is kind of our p-hat value. Okay, they're asking us this time to carry a significance test out at an alpha level of 0.10. Okay, so what this means is since we have a higher significance level, our p-value doesn't have to be as small. Okay, what should be our proper conclusion? You can see here we've got the claim or the parameter we're testing is the true population proportion of potatoes in the shipment that have blemishes. Okay, we're testing that against the idea that maybe more of them would have blemishes. That's why we have a greater than. Okay, you can see all our conditions are met here. Okay, we're calling this a one proportion z-test. And I've got all of our numbers plugged in. This is our sample proportion. This is the claim from the null hypothesis, okay, which is what we use here for p. And then this is 1 minus p sub 0. And remember, that's your n. Okay, so here, it's just one-tailed. Okay, our z-score is 1.15, so we're going to say maybe that falls right about here. We're doing greater than. Okay, so to get our p-value, we're going to go all the way to the right, lower, upper, okay, and this is going to give us a p-value of 0.1251. Okay, so when I make my decision on this, I'm linking together the relationship of the p-value, 0.1251, as that relates to the alpha level of 0.10, and it's greater than. So we're going to say we fail to reject the null hypothesis. Okay, this means we don't have enough evidence. We do not have convincing evidence. Okay, and we're always making the statement about the alternative, that the true population proportion of blemished potatoes in the shipment is greater than 8%. Okay, and we're just going to put some good communication here. So our advice, they should make chips from this shipment. Okay, that would be our advice to them, that they should make chips from this shipment. Okay, so what we're going to do is we're going to take a look at how can we do this on our calculator. By the way, when I suggest that we do this on the calculator is only going to do this part for you, like the do step. You still have to do all these other parts. You have to make these statements here, you have to name the test, you have to check the conditions, all that. But I like to take this problem. On the next page here, we're going to just kind of walk through how these screenshots look real quick here for if we were going to perform this just on our calculator. Okay, so what you would be looking for, as we said, is on the calculator, this is called a one proportion z-test. So that's where you would want to go on the calculator and select that test. Okay, now it's going to ask you for a variety of inputs here. Okay, it's going to ask you for p sub 0. Of course, we know that just comes from the null hypothesis. X, that's going to be like how many blemished potatoes were there in the sample. So in this example, you're going to input 47 there. Obviously, N is 500, and then it's going to want to know what was the inequality symbol that was used in the alternative hypothesis. Was it a does not equal to, a less than, or a greater than? And on this problem, we would want to highlight greater than. Okay, now you have two options. If you select the draw feature, it's going to kind of draw that bell-shaped curve, show you the shaded area, and at the bottom it'll give you the test statistic, which was the z-score. It'll also give you the p-value. Okay, if you just select calculate, which is often what I do, but it doesn't matter. I guess if we're wanting to draw the curve, You could pick the draw one. Here it's also going to give you the z-value, and it'll give you the p-value. Okay, those are the two things that we need to write down, as well as it is always a great idea to draw the curve. Okay, it mentions here in this little AP exam tip that you have to always name the procedure, which is a 1 proportion z-test. You always have to report the test statistic, in this example 1.15, and report the p-value. Okay, now you'll notice this p-value is slightly different than the one when we did it by hand and plugged it into the actual formula, and that's entirely fine. Okay, that's okay. It's close enough. We're still going to be arriving at the same conclusion there, so that's good enough. Okay, so I encourage you, whenever you're doing your homework, to maybe try a problem or two for the do part, to use the calculator. But I would discourage you from doing all of the problems that way, for the exact same reason we said before with the confidence intervals. You're going to run into multiple choice questions, and so you still want to be familiar with how those formulas look. Okay, so this is the last one we're going to do for this video, which is this smoking in high school, and I filled in parts of this here for us. But this is going to be a good example of kind of going through a two-tailed test with you. It says, according to the Centers for Disease Control and Prevention, this is the CDC website, 50% of high school students have never smoked a cigarette. Now, Tanyan wonders whether this national result holds true in his large urban high school. So for his AP Statistics class project, he surveys a simple random sample of 150 students from his school, and this is the response he gets. Of the 150, 90 say that they have never smoked. Okay, so that means that the sample proportion is 90 out of the 150, which is 0.60. 60% of them are saying they've never smoked. What should he conclude? We need to give appropriate evidence. Evidence is a key word that we're doing a significance test. So our parameter in question is the true population proportion of students at Tanyan's school who say that they've never smoked. Okay, the null is 0.50. That's just half, which is what the CDC says. And it doesn't mention that he thinks that there's more or he thinks that there's less. And so when you're not getting a vibe of, kind of going against a certain claim more or less, that's when you would want to use a does not equal to. Okay, we're going to pick our own significance level since it was not stated. We're going to do 0.05. Okay, you'll notice here all the conditions appear to be met just fine. Random 10%, large counts. Okay, we're naming the test a 1 proportion z-test. Okay, I'm going to go ahead and plug this here into the formula. It gives me a z-score of 2.54. If you wanted to try these two steps here with the calculator, you could. Okay. So right here in the middle, 0. Remember, this was a two-tailed. So I'm going to go to the right. 1, 2, 3. Say right here's 2.45. I'm shading to the right. I'm also going to the left. I'm going to say this is negative 2.45. Shading to the left. Okay, two-tailed like that. Okay, now when you do two-tailed on the calculator, the p-value they give you has already been doubled. If you do it by hand, you have to, and obviously, if I'm going to do normal CDF, and I'm just going to go 2.45 to 10,000, I know that's only representing in one tail, so I'm going to need to multiply that value times 2. And that gives me a p-value of 0.0143. Might be slightly different than what you possibly could be seeing on your screen if you're doing that on the calculator, but that's okay. You're going to say, since the p-value of 0.0143 is less than the alpha level of 0.05, we're going to reject the null hypothesis, and our conclusion here is going to be there is convincing evidence that the true population proportion of students at this high school who say they have never smoked is, remember this is in favor of the alternative, so when it's a does not equal to, we just say it's different from 0.50. We don't say greater, we don't say less, we just say that it is different. Okay? All right, great.